Hello and welcome to this video on simplifying rational expression rules and common mistakes to look out for. To start off with, we're going to look through some steps for how you should go about simplifying rational expressions in general. Now, we have steps 1 through 5 that we're going to look at in front of us right here. You're basically going to have some form of polynomial in your numerator and your denominator. So you want to pick the numerator or denominator that is simpler for you to handle. So when you're trying to simplify the numerator or denominator, you want to first look, do you have any common factors? For example, the expression we have in front of us, 3x squared plus 9x, those two things have 3x in common. So I would factor out 3x and leave behind x plus 3. There are also some special cases to look out for. One being the difference of squares you might remember from the past, 4x squared minus 9. So it would factor into these two parentheses. Whenever you have two things that are perfect squares, you can do basically the square root of them separately and just do the first put in both places, and then you have the minus version of the same thing. Because like square root of 4 is 2, the square root of x squared is x. The square root of 9 is 3. So you just have positive and negative. Then you have just regular quadratic factoring, or where you have perfect squares in general. So x squared plus 6x plus 9, that means that you'd add up to 6 and multiply to 9. So you could write that as x plus 3 times itself. Or that would be the same thing as x plus 3, the parentheses squared. You'd want to be able to factor the numerator and denominator as much as possible, and then we'll see multiplying and dividing more later, where you're going to be doing that with two fractions right next to each other potentially. And then finally, you want to get rid of all of your common factors by dividing those out or canceling, quote unquote, like we talked about in our last video. Also, keep in mind that you might have factors that are the exact reverse of other factors. And in that case, you might need to factor out or divide out a -1. For example, 2x minus 3, if you take -1 out of it, everything becomes the opposite. With the minus 3 will become a positive 3, the 2x will become a negative 2x. So these steps that I have here, so you may want to pause and write down the first 3 steps here. So pause the video now to write down those steps. And then for steps 4 and 5, you can pause the video here to write down those steps. Now that you've done that, we can look ahead at some common examples you might run into where these contain very common mistakes that students make in this topic and in this chapter in general. So to start off with number 1, we have the top is x minus 5 and the bottom is 5 minus x. Now at first glance, they don't have any common terms and they're only separated by minus. But what we need to remember is the -1 thing, part 5. So we have x minus 5 on the top, but if I take a -1 out of the bottom, well, that would make it into -5 plus x, because everything is kind of the opposite sign now. And then if I just rearrange the bottom part, that means that I would have x minus 5, and then -1, and then x minus 5. So in that case, I can now divide out the two x minus 5s, and this a different color might come in handy. And that means that we would just have nothing left on the top, which doesn't mean that it's 0. It means that I have a 1 if I have nothing left, and then a -1 on the bottom, which means that the whole thing is going to be equal to -1. Number 2, we have on the top x plus 5, and on the bottom 5 plus x. Well, those are the exact same, just in a different order. So I would first write it as x plus 5 on the top, and then rearrange the bottom one to be also x plus 5. And now I can just divide something by itself, and I just know that it's going to be equal to 1. Now, number 3, we have x minus 5 and x plus 5. So like our common misconception from our last video, we want to look at x minus 5 and x plus 5. Well, there's nothing actually you can do with that. X minus 5 is as factored as it gets. X plus 5 is as factored as it gets. So that would be the final answer already. Nothing we can do about that one. Number 4, also a pretty easy one because we have x minus 5 dividing it by itself. So that is another one that's going to be equal to positive 1. And lastly, to end these common mistake problems is an example of the future where we're multiplying two fractions. So the first thing I'm going to do is, well, can I factor anything in the top and bottom? So x minus 2 and 2, those are both as basically prime numbers, essentially. So I would just write x minus 2 and then a 2 right here. And then the 4, I could write it as 2 times 2. But you can kind of just think of it as a 4 if you want. You don't have to write it as 2 times 2. And then x squared minus 4 as a difference of squares. So that means that we would have the square root of x squared is x. The square root of 4 is 2. And then I would have the plus and minus version of that very same thing. So now you can notice that any addition or subtraction that we have in the problem is inside of a parentheses. Outside of parentheses, we have nothing that's addition or subtraction. So the first thing I would do is divide out a 2 on the top and the bottom. So those are divided out and they're gone. And then I would divide out the x minus 2 and x minus 2 right there and there. So the only thing I have left on the top now is a 2. And the only thing I have left on the bottom is x plus 2. And that would mean that I am left with prime stuff on the top and bottom, and that the problem itself is finished. And that covers 5 examples that contain common errors that students make on simplifying rational expression problems. And we covered our rules for doing this in the first part of the video. And that concludes this video in general. Thank you for watching.